This lesson deals with Supplemental Problem 2.9. You can find this problem in the course ebook in the Chapter 2 Supplemental Problems on page 10. Given this circuit, could you find the equivalent resistance looking in terminals A and B? To be in series, two elements need to share the same current. The 8 and 16 ohms share the same current, so we can combine these by just adding their values. So 8 plus 16 is 24. To be in parallel, we have to share the same two nodes. Here's a node. Here's a connection point, but all this is one node. So 6 in parallel with 12 would be the product, which would be 72 over the sum of 18. That's actually divisible by 4. Now I have the same current in these two elements, so I can add them together, and that would give me 8 plus 4 or 12, and then 12 is in parallel with 24. That'd be the product over the sum, 12 times 24 divided by 12 plus 24. Now if you divide the numerator and denominator by 12, you get 24 in the numerator, and you get 1 plus 2 or 3. So 24 divided by 3 is 8. You can also use your calculator to do the same thing. That shares the same current with a 24 ohm. Add those two together, it gives me 32, and then that's going to be in parallel with 32. Now when you have two resistors in parallel that are the same value, their parallel combination is half. 32 divided by 2 is 16. And lastly, we have a 4 ohm sharing the same current with 16, and that would give me 20 ohms for R equivalent. And this is Supplemental Problem 2.9.